A good story on this one that I'll tell you is when Viptela got acquired into Cisco, there was this conversation around would it be a separate business unit or not?
Mm-hmm.
Right? Would it operate like Meraki, where Meraki has been able to operate quite independently for a very long time, which has been very good for them. At that point, it was a decision, no, it's not. So people were, okay, but does that mean you're going to invest in it? Or is this going away?
Mm-hmm.
It definitely got integrated into the ecosystem, but it was a painful integration. There was a lot of lessons learned along the way. There were a lot of bumps along the way. And a lot of customers had to be re-won in terms of satisfaction because they were very unhappy with the experience they were getting. Prices went up, and not by a little, by a lot, by a lot.
A week before we recorded this, Lumen agreed to buy Alkira for $475 million. Alkira was one of two leading independent network as a service companies left in the enterprise market. With this deal, there's basically one. Today's guest runs it. If you're a buyer who signed a multi-year networking contract recently or is about to, this is for you. I'm Max Clark. This is signed. My guest is Ali Shakh, the CEO of Graphiant. Okay, let's dig into it and let's get into the elephant. Let me start with the elephant, right? So when we're recording this, what is it, like a week and a half, 2 weeks ago, Lumen announces they're acquiring your competitor, right? Now, there's a whole lot I'm fascinated with in this one, right? And of course, your background, you've been through a few of these. Mm-hmm. You've been on the acquired side of things, and what's interesting about it, and I'm gonna kind of throw a bunch of stuff, but I'm gonna try to stay in a little bit of a linear thing here, right? What's first and foremost, though, being on the side that's been acquired, you got a lot of people that are now making commentary, and you got a lot of presses trying to fill in some blanks. You've got the press releases from the companies themselves. What do outsiders get wrong about these acquisitions and what's going on the inside as they're happening?
So first of all, I think I'm going to acknowledge how exciting and great news it is.
Yeah.
Alkira is part of the family. Mm-hmm. Amir, Atif. Atif was the one who hired me into Viptela. So the history goes way back. They're sister company, and I never saw them as competitors. So it is a beautiful thing. I'm very, very happy for their success and for the success of all the people at Alkira. So it's a wonderful, wonderful thing to have happen. Now, to answer the question that you asked about what people don't know, just the acquisition itself, when these things happen, it isn't an immediate kumbaya, wonderful, happy, fun times. A lot of work happens, even as part of the acquisition. Just the act of going through an acquisition is itself a very painful ordeal. So a lot of what they are going through now is going to be integrating into Lumen's ecosystem. And that is a very, very painful thing to go through when you are the acquiree, or the acquired, not the acquiree.
Yeah.
And so that ends up being the thing that people really, misunderstand. Oh, huge windfall, lots of money coming in. The work that goes in, the work that now begins will be something tremendous. It will be several quarters of how do you align the go-to-market strategies on the seller side? What happens to existing arrangements with partners and ecosystem players? How do you integrate this into the existing offerings? Does it work with the existing offerings? Is it going to be a separate business unit? Does it get merged into existing business units? What does the engineering effort look like to first onboard the existing ecosystem inside a place like Lumen? And then how do you integrate? And then how do you iterate and evolve? Very painful. And this, even when a tech company absorbs another tech company, it's still difficult. So when a carrier absorbs a tech company, that comes with its own challenges. And I'm ignoring all the human element of the politics and the budgets and everything else. Just the effort that goes into it, people really underestimate how much work it is.
If you're a carrier agnostic networking company, right? And some sort of overlay, underlay, side lay, whatever, the proper terminology is now. And then you're acquired by a carrier. That creates some friction as well, right? And I mean, again, we're so like the acquisition hasn't closed yet, so I mean to call this like early innings, but it's more of like a foreshadowing, right? So how does the go to market then evolve? There's the one side of it, which is how much additional network asset does Lumen sell off, and it's just this a reactionary, hey, we've sold off all of our prime network asset, and now we need to have something that we can sell as a network, right? I've talked about that with people, but from a carrier agnostic situation to then be acquired by a carrier who makes money by selling their own network.
It's when you have to think about the network as a service space as it's evolving and how the carriers and vendors have to look at this. The carriers have to find a way to drive differentiation, because otherwise everybody has circuits, everybody has the same VLANs, everybody has the same MPLS, everybody has technology-wise from a carrier. There's very little that differentiates them. One carrier is more or less the same as the other carrier, for good or bad reasons. When you are an end consumer, you're looking for the best possible service, and you don't really care how it gets built or how it gets done. When new software capabilities arise, when new vendors arise, a carrier really has to think about, does this help us deliver a better service or not? Now, for a vendor that has built a technology that was carrier agnostic and suddenly is getting absorbed by a carrier, that's the harder part around, well, their motivation is very clear. They have to find something differentiated that nobody else has. But when you're the entity that's being acquired, it does paint you into a difficult corner of, well, I had all these relationships with all these other carriers and all these other service providers and all these channel partners and people who are doing all these different things. That's all up for debate now. The end statement that you have to rationalize is, does the acquisition and being part of this carrier and exclusively to this carrier in the long term benefit the outcome that you want?
Network as a service, right? Emerging space, right? And different people. The thing that drives me crazy in tech and is like how terminology starts, but people have different intentions behind that terminology. Absolutely. Or then they try to shoehorn into categories. SD-WAN, like everybody and their brother was an SD-WAN company, and like, what did that actually mean? But you look at the original like inception of SD-WAN, the intent, it was, you've got a very expensive MPLS network that's not very flexible for you, and we're trying to, whether it was create flexibility and for your operations, or it was, drive down costs for you because you've got this really expensive network, and I really believe a lot of it was just looking for an easier way to operate and be a customer of these networks, right? And so when I look at this acquisition, I'm like, how much of this is just trying to compete with the fact of, carriers and telcos make it very difficult to do business with them. Like the whole idea of like, just be easy to work with, it's like, then you interact with a telco and you're like, okay, great. Now what do we do, right?
It's so true. I think even when you look back to the SD-WAN aspect itself, the networking purists will say, well, it wasn't even about the MPLS internet thing. It was fundamentally, how do you separate control plane and data plane? How do you apply SDN principles? Because the classical MPLS VPNs, right, that's tightly coupled control plane, data plane. This was like the first application of SDN principles to wide area networking. Now, the purists will say that's what SD-WAN supposed to mean. It became, how do you offset expensive MPLS circuits with commodity internet, and it drove the market based on that. So even when you have the almost philosophical purity of what the tech was built on, it can still change. And the market can change definitions and terms in lots of different ways. So when I see NAS and what I see with the Alkira acquisition, I have to really recognize the carrier is fundamentally not even really thinking about what a network as a service definition is, or what the principles were that drove Alkira in terms of how it got created, or other NAS companies. They are fundamentally looking at, we have a giant hole in our portfolio. We have to sell something that is differentiated from all the other carriers, and we're going to do it this way. So the NAS definition, it's so vague in this construct, right? Like, what are they thinking about NAS in this to begin with? And fundamentally, you can make the argument, because they've promoted it, they claim to already have NAS. So why would you buy NAS if you already have NAS? And the definition things can get murky that way.
I listen. I you know I don't want to like pick on telcos and carriers and big carriers, but there's this funny thing that happens, which is as you're successful and you get big and you have a lot of assets, you have a lot of infrastructure, you have a lot of equipment, you have a lot of like you get to a point where you're unmanageable, and you end up there because you're too big, right? So then somebody starts at smaller, and we've seen this with backbones all the time. Somebody can start up smaller, and they have less infrastructure, so they're more nimble, they can respond faster, they have more efficiency, you know, like you're just touching less devices. And maybe they start without all that legacy cruft, and they can say, oh, you know, we can build a config automation platform that's, you know, has a web interface to a database that's going to build a config and push it to a router. And then you go to the next step where it's like, okay, now we're going to do this with, Terraform, and we're going to get into infrastructure as code, you know, kind of principles, or we're going to use FlowSpec to push, you know, config out. But it's like, we don't have the legacy investment of like 10, 15 years worth of gear that you have to maintain. So I get that cycle. But then, you know, there's the other side of it, which is like, how hard is the network to deploy and manage? But then it's just, how hard are you to work with, because you're trying to force contract structures, right? Like the initial push for NAS was just like, hey, I'm not going to force you into a 5-year contract. You know?
And honestly, the point that you're highlighting is what it'll always come back to. The tech is never the problem. NAS, even when we started out, you know, with Graphiant to build out all of this, a huge component of it was the commercial structures, the licensing models, the contractual structures around these things. Because the tech you could have evolved in lots of different ways. And that holds true for NAS in a lot of different ways. It really does come down to how easy is it to do business? Why are there 28 different license tiers? I mean, and it's just those kinds of things that drive people crazy. The tech could otherwise organically evolve. We've seen that happen in telco space and network space for so long, where a certain kind of financial model, some mix match of CapEx and OpEx and the license SKUs that get created along the way, become so rigid that you are almost forced as a carrier to incentivize the market almost, hey, can someone go out there, create something new? Because we can't get out of our own way.
That's a great point. I don't want to. I'm gonna touch a few more questions on this, and I don't want to make the whole thing about this. From a customer standpoint, you know, again, you've been on the vendor, I'll say the vendor side, the provider side of this. From a customer standpoint, you've just done a deal, and then you find out that your like network strategy core component linchpin piece was just bought by somebody. You know, besides the initial like panic and like, what did we just do, that like sets in, what do they need to be asking? Like, how do you go through? I mean, now look, it takes time, right? So your first one is like, how long does it take for the acquisition to close, and then what happens post acquisition, and then what's integration? So I mean, we could be talking about years worth of, you know, whatever before something changes. But for a person in that perspective, you know, when you were sitting across the table from a customer, you know, Viptela in previous life, right? You went through this. So what questions are they asking, and how do you make this softer for them?
So it's a balancing act that ends up happening when these things happen. One is customers feel de-risked. So there is that sense of comfort. Oh, this small company got bought out by a big company. It won't disappear overnight. So there's definitely that element of, so they suddenly feel much more easy. But if they were already ready to do business, then that was a risk that was acceptable. So it doesn't really move the needle by that much. The two things that come up almost immediately are you going to jack up the prices? And two, if not that, are you going to kill this product line because you have 28 other products inside your portfolio, and this is almost a means to acquire customers, talent, but you don't actually intend to keep this product alive for very much longer, for whatever reasons you might have. Those two are the things that the customers immediately think of, as they should. Invariably, when these things in network infrastructure, you typically don't see too many things get killed off that fast. Nothing happens that fast. So the lifetime is long enough, but people tend to notice development slows down, bugs creep in a whole bunch, product quality stops, a lot of the key talent starts to move on. Mm-hmm. Those are signals that customers are, okay, this is not really going to be around for very much longer or going to see much development. And the prices still go up. So that's something that customers are very sensitive to, as they should be. And so when they think about this acquisition, they should simultaneously be looking at the carrier and saying, are you going to raise the prices? And what's your investment plan? Not a product roadmap, but an investment plan into this. Do you intend to continue to grow this and develop this? And alternatively, they should be looking at other vendors in the space to say, okay, if this is happening, what's my hedge? If this goes sideways, I should be prepared. If I need to adjust for costs or if I need to adjust for the fact that this product won't be there. A good story on this one that I'll tell you is when Viptela got acquired into Cisco, there was this conversation around, would it be a separate business unit or not? Mm-hmm. Right? Would it operate like Meraki, where Meraki has been able to operate quite independently for a very long time, mm-hmm. which has been very good for them. At that point, it was a decision, no, it's not. So people were, okay, but does that mean you're going to invest in it? Or is this going away? Mm-hmm. It definitely got integrated into the ecosystem, but it was a painful integration. There was a lot of lessons learned along the way. There were a lot of bumps along the way. And a lot of customers had to be re-won in terms of satisfaction because they were very unhappy with the experience they were getting. Prices went up, and not by a little, by a lot, mm-hmm. by a lot. And so there was a lot of those questions that even if there were answers, the answers weren't the best answers. The customers experienced time of prices going up, quality not being great, not really having clarity on if this was going to be around for the long haul or not.
Okay. Let's segue into this for a little bit, right? There's another monster integration acquisition going on right now. We have mm-hmm. HP buying Juniper, we think. And I took some heat on that online because, I was just posing the question of like, what product survives this integration? Mm-hmm. And who comes out on top? And you can see that usually by the executive teams, like who's put in charge of whatever segment they have. But HP has a lot of overlapping segments now. Mm-hmm. Cisco had the same problem, or still does have the same problem, right? You've got your legacy router line, you've got your legacy switch. I mean, say legacy, right? But you have your ISR line, you have your switch line, you have your Catalyst line. Then you go out and you buy Meraki. Now you've got your like next gen SD-WAN, SDN, mm-hmm. Line that you then have to integrate in your product line. You go out and you buy Viptela. You have your own SD-WAN that you're trying to bring to market. You've got this SD-WAN you're trying to bring to market. And so my natural reaction to all this becomes, what are we investing in? And how much do we trust? Has there been any, can we infer any signals that come out of it to make me believe that this is safe?
That's a good question. And it plays out two ways, whether a vendor acquires or a carrier acquires. Mm-hmm. The carriers are so operations focused and they have to be operator oriented that they have to make those kinds of decisions around, are we going to keep investing in this because it's part of our operational framework? With vendors, especially the large ones, they become holding companies. They end up having all of these product lines still there, even if they compete with each other in almost every way possible. So when I look at HP and I think about the fact that it has Aruba, Silver Peak, Juniper Mist, mm-hmm. they're going to have 6, 7, 8 different product lines. Mm-hmm. And even and they'll still have the 128 technologies mm-hmm. piece that folds into Mist. So you've got layers upon layers. I don't necessarily think any of them go away. I think all of them will be in some shape or form there. The question really becomes, which ones are seeing investment and which ones are seeing their prices go up?
I mean, this is the Oracle model, right? Oracle buys something and it doesn't kill it. Is it invested? Maybe, maybe not. I mean, a lot of these things don't feel like they have any investment or forward motion, but they have an entrenched customer base that can't get off of them.
Yep.
And then what can they do? They can just turn the dial and we see, Broadcom's doing this with VMware, right? They just know they can just turn the dial.
And what are you going to do? I mean, as much as people talk about Proxmox or OpenStack or KVM, that is not easy. And VMware built a very solid, credible base, and they had a very, very, very good hypervisor solution.
Well, so then you're dealing with two different issues, right? You're dealing with a technology issue. Can you go to another HCI system or a virtualization platform, right? And for, I don't know, probably 95% of people, they're not using the full VMware stack of what it does. So yet you could go, I mean, you don't even have to go to Proxmox. You can just run KVM or yourself on a box, right?
Yep.
We do that. It works great, actually, But then you have this other side of it, which is always the people side. And this is the part where I'm like, man, I never thought I would become a network engineer and then have to study like psychology along the way, right? But you kind of like learn these lessons painfully of, we call them like the layer 8 issues.
Absolutely.
Companies associate risk, and it becomes inferred pain risk decision-making process. Okay, VMware just got really expensive. My finance team is yelling at me. I'm in trouble, but I'm not really in trouble because it wasn't me doing it.
Exactly.
And I'm like, and it's like, sorry, I can't do anything about it. It's like, it's just more expensive. Oh, we could migrate, but we think it's going to take a year, and a lot of money.
And it becomes fuzzy, where it's ironic, where the world of sales, marketing, and everything has become much more by the numbers, much more fact-oriented around, is this going to happen? Is this not going to happen? Is this the deadline? Whereas engineering has become increasingly fuzzy as around, well, this project is a 2.5-year project. Based on what? Vibes.
Based on vibes.
And so this is where I think, in a way, when we look at the network infrastructures landscape, this itself it's a lower churn rate space. People compound risk there because no one wants to mess with infrastructure. People worry if something breaks down. And when they think about the technologies that they're comfortable using, I think it goes to what you made the comment about psychology. There are people who have said to me, hey, I put my kids through college on that vendor. Why would I touch any of it? And then you see decision-making is so far removed and so distributed around. You have the decision makers, budget owners who don't know the tech, the engineers who can, for various motivations, say we do or don't want to do something. And then people who are really passionate about new tech, they can sometimes be just lone voices in the wilderness who are just saying, this is very cool. We should be able to do this. This would save our lives, help us, save a lot of time, enable new things. But everybody else says, but do we really want to? Do we really want to rock the boat that much? And so it's a hard game, and it is definitely a huge amount of it is just psychology.
It's an interesting double-edged sword problem for you, though, right? You start talking about like entrenched technology that has very low churn. So immediately people go, oh, this is great to sell and be in because you have very low churn, but you have to go sell into an environment that's very low churn and convince them that what they're currently doing they shouldn't do anymore, and then take on the risk of change. And that makes your process interesting, right?
Absolutely. In infrastructure, I think that is reflective of the fact that infrastructure is the only real moat. When you think about pure software capabilities, pure application layer capabilities, increasingly they're more easily replicable. If you wanted to be a fintech tomorrow, it is a much lower barrier of entry. You can actually code pretty much everything that you would get in most of those financial services yourself now. Spend a couple of weeks in Claude Code and suddenly you'll find you have your own fintech.
Oh, please.
But that's the thing, right? It's the underlying infrastructure. That's the moat. That's the hard part. Do you have the right network built the right way? The data structures, how to use the data that you have, where to house it to begin with. Do you have the right encryption, the right compliance? Yes, it's a harder place to go into to drive transformation and upgrades, but it is the relevant place. It is the thing that endures. And that's why you have low churn, because it is the place that endures. You have so many different applications that will come and go, and you can swap them so easily now. But infrastructure is meant to be something durable.
I still call myself a network engineer, even though I'm not like configuring routers that much anymore day to day. When SD-WAN came out, and there was the what we're trying to solve, and then versus what people were deploying it to solve, were disconnected for me in a lot of ways. And there was a segment for me that was just, we didn't have the talent inside of the enterprise to actually manage a network anymore, and so we could just displace that onto this magic box that did certain things for us. You know, how many SD-WANs were just site-to-site VPNs that were just auto-configured between the devices, right?
Excellent.
So then you get into a situation where it's like, okay, I don't have network engineering talent, or my supposition, right? You don't have the network engineering talent, so you can get the magic box that does the networking for you, which you still have to deploy and manage, right? Which creates its own operational overhead and cost. And then now we see this emergence of NAS. So in that world, like that, like very small box of like, okay, you can do all this yourself still if you had the ability to do it all yourself, but you don't have. So is NAS now just a reinvention of where the actual of the box? We've taken the physical box away and we've moved it into a hosted service?
I don't think that that's where that is. I think that the big difference is, you're right in sort of the SD-WAN experience of people wanted to get away from the lock-in that they had. They wanted new capabilities and they wanted them quickly. So SD-WAN felt very appealing for those reasons. Oh, I'll get internet connections. I can connect into the cloud. I can do a bunch of things. Whereas trying to renegotiate a carrier contract would take too long. So that happened. They deploy. They realize it is non-trivial. It comes with a tremendous amount of complexity. And you almost have to relearn all the things that you probably had forgotten or never bothered to learn to begin with. Right? You go into an application, there's a bunch of DevOps teams and they don't know what BGP is.
Oh, geez. I don't want to throw any shade on DevOps, but I have so many bad stories.
But that wasn't their domain expertise, and now they're having to build automation and tooling for a system that operates very differently. That then leads into the enterprise starting to shift the running of the SD-WANs that they had purchased and deployed to all the different MSPs, MSSPs, CSPs, whoever would take on the complexity. And so the carriers were, again, one of those who started to absorb a lot of that complexity. That complexity comes with margin hit for them. So financially, the SD-WANs have not been good for the network carriers. They inherited far too much complexity for a thing that was designed for enterprise, not the carriers, and it affects their numbers. The enterprises are happy either way, right? They bought it, they get to use it, they benefit from it, and they have found a vehicle to offload the complexity. When we think about network as a service, I think this is an opportunity for the carriers to reset the table a little bit if they are wise about it, which is we're entering this world where the consumption patterns will change. The human beings aren't the only audience we have to cater to. The networks are going to get more complicated because we're going to use not just the public clouds and the data centers. We're going to use GPU wherever on earth we can find it. So the complexity is going to go up. There will be increasing demands on your classic C-suite to be like, I want this to be rock solid. Your network engineering teams to go, I need new capabilities, but I don't want to lose my job. And then the whole agentic side of, we don't really care about any of this stuff. The agent just needs to deploy this workload and it doesn't care, and it'll find a way to bypass the system. If you're a carrier, you have to think about, can I create a service that has that on-demand functionality for this agentic world? It'll just want dynamic networks here and there. Does it help the existing engineers appreciate new capabilities so they aren't feeling like they're about to get eliminated? In fact, they're being enhanced in terms of new capabilities about new optionality of how to construct networks. And the executives who are just going to say, is there AI adoption? And you can just say, yes, there is. This is happening. It's an evolution. And I think network as a service is that vehicle because the tech can evolve on its own. These are contracts and relationship vehicle changes that we need to revisit. We don't need 10,000 licenses. We don't need to bury people in complexity. We have to find a way to simplify the business relationship. Now, granted, the carriers have not historically been the best to do that, But that is the fundamental ethos of network as a service. Can we create a business relationship that makes it better to transact, do these things, build the networks that we need, enhance our capabilities without making it so difficult? That, I believe, is the ethos of network as a service.
There's so much I want to unpack in that. Okay, I have a very primitive view on a lot of things. So let's start from my really primitive view on a lot of things. The first misconception dealing with for decades now is what MPLS actually is. And I don't care what the terminology is. MPLS, VPLS, IPVPN, blah, 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 this, blah, blah, blah. People call it waves. It's not. There's very little networks that have an optical core with an Ethernet service layer, right? But you talk about operational complexity. If you're building on an MPLS network between two different geographies with two different underlying carriers, right? Now you've just displaced that. I mean, it's a great point, right? Because you went to whatever your primary integration operating carrier was, and they went out and they bought the circuit from somebody else and they integrated. Now, of course, you're talking about two horrendously bad operational companies dealing with each other to then deliver a circuit. And you're like, yeah, that took us 9 months. And you're like, of course it took you 9 months. There's reasons why people like me exist, because we just yell at people every day. Right. We do it politely, but I mean, fundamentally that becomes part of the, where are you in this process? Now you touched on two things that were very fascinating. The first one was, shifting costs and margin and who's actually the operational provider for it. And then where does that integration actually take place and where does it get operated and managed from? And on one side of the coin, you're making a pitch towards a carrier where now the carrier can offer the service in a more efficient basis. But on the other side of the coin, you've just commoditized the carrier to the absolute purest form of saying, oh, great, go out and buy whatever cheapo internet circuit you can get from this carrier in this location. It doesn't matter because there's nothing smart or intelligent or fancy there. So now you have, are you friendly with the carriers or are you competitive with the carrier, in that world?
There's two elements to this and two competing tracks almost, but let me walk you through how we envision and how we experience it as well. When we look at the network as a service from a business vehicle standpoint, we have made it easy to transact. And what we see is when you make it easier to transact, even across carriers, it actually accelerates the business. Right? These delays, these 9 months to get a circuit, make you angry, make you not want to do more business. If the business happens very quickly, you're incentivized to do more. And so we see that organic growth by virtue of NAS being easy to transact, even if it's a commodity, right? So even on the commoditization side, the acceleration of revenue is there. So that plays to the carriers, it plays to the vendors, it plays in all of our favors that it makes it easier to transact. No one should have to buy a 5-year term contract if they don't need to. So that's one part. I think the commoditization of a lot of things does help. We would say commoditization, another word for that would be standardization, where if it's applicable everywhere, then it's available to everyone in a way that business can be done easily. So that's one part. The other side would end up being is when a carrier sees, oh, if you've commoditized me completely, right? There's no value that's coming from some of these other things that I used to provide. It's really a question of, okay, how do you provide that differentiation? How do you provide value? And realistically, the carriers have to move in the direction of just the circuit in and of itself does not provide value. The value comes from how do you accelerate new opportunities for the data. Just having fiber optic means nothing unless it doesn't connect you to the relevant places you want to go to. If I want GPU as a service on demand, that's what your circuit is supposed to facilitate for me. It's much more about outcomes than what it is the thing that you provide. Because the thing that you've provided is in a way commoditized. The fiber optic in the earth is a commodity. Sunlight is a commodity. Oil is a commodity. It's the outcome that you can drive that differentiates you. So if you are connected into more GPU as a service places, into more public clouds, into private clouds, if you make it easier to move the data with compliance, with risk assurance. That's the value. Because an enterprise doesn't want to figure out how to do that. That's not their core competency. They would much rather somebody else did that. That is an outcome that service providers, that service integrators, that consultants, advisors, that's the outcome. That's where value will be created. Because otherwise, if you ask me, if none of that is done, is a carrier commoditized? The answer is yes. They're one hop away from being a utility.
Been doing this too long. We used to have, some sort of optical layer, and then it was like ATM or Sonnet, and then Ethernet came out on top of it. So that what we consider the internet was like, what was a core, layer 2? Then what was, you can argue whether ATM and Sonnet, where it really fits. I'm not going to get into that argument. Please argue with me online. And then we had the internet, like Ethernet put on top of it, right? So you had this delineation, and then you get, SD-WAN and stacked on top of it, right? So it's like, I think, and now these two have been collapsed typically for most carriers, right? So, the joke for me almost all the time is MPLS is the internet, is an MPLS or VPLS or whatever term, who cares? So, and in terms of like, are you buying MPLS from a carrier? Are you buying internet from a carrier? Are you running your own VPN, SDP, ZTNA, whatever the heck you want to call it, fill in the blank, on top of that, and so when we start talking about like network as a service, we're talking about like a contractual operating model, but we're also talking about what the end user is actually receiving and doing with it.
Yeah.
And it's like, oh, you want to go out and acquire GPU as a service from somewhere. Well, that somewhere's connected to the internet already. You can talk to it via the internet. You can use HTTPS and encrypt your internet traffic. You can run a VPN on top of it. WireGuard is not that complex or have a lot much overhead on top of it. You can run any one of these, ZTNA, different SDPs. There's lots of different things there. So why is that customer then driving into, we need to reinvent what looks like MPLS again in a different way with a network as a service provider to then go talk to a GPU that's here versus here versus here versus, some other pipe, right?
So I think it starts from the outcome that you want. The outcome being, if this is a business relationship that allows us to connect anywhere on demand, if that's our start point, then we start engineering in terms of, okay, what the technical elements are. Could you use ZTNA in some space? Would you use MPLS as an underlay in some locations, or VPLS, layer 2? All those technology elements can be part of the solution. The network as a service has to be able to do all of those things. Too often, I think we have done this thing where we created a tech, whether it was frame relay, ATM, IP/MPLS VPNs, SD-WAN, SASE, all of these things. These are technical constructs that we created, and then we would jam through a business relationship. And you got licenses, and you got all these tiers. MPLS VPNs, whether it was L2 or L3, you had different QoS, and then you would be charged on each QoS profile. Being charged on CAR, or all these different constructs that come around. Similarly with SD-WAN. Oh, you're going to get a branch license, but then you also have a maintenance license, then you have a security license, then you have a boost performance license, then you have a license to turn on certain things on the ASIC. Technical architectures being jammed into a business model. I think network as a service has to, and the time in the world kind of demands that, is we don't really care if it's IPVPN, WireGuard, MPLS VPN, segment routing, doesn't matter what's under the hood. Do we agree that the outcome we want is this, which is, if I want an on-demand connection into GPU as a service cluster over there, my data resides here, I use these public clouds, and I want it to be uniform, and I want it to be secure. I don't want to think about how that happens, but this is the contractual vehicle I want with the vendor, the supplier, the carrier. That is the NAS start point. Now, how do you solve that? This is where now you can have a more honest conversation about what are the limits of point-to-point VPNs? What are the limits of multi-point VPNs? What are the limits of MPLS VPNs? Do you layer on encryption on top of an MPLS VPN? Where do you benefit from segment routing? Do we get into the religious debate of IPv4 and IPv6? You can go into all of these things, but now you have the honesty about it, which is forget the licensing. Forget all of this other stuff. This is the outcome we want. Can we build it? And this is where for us, even on our journey, it was, we would have all these debates at Graphiant and even before. It was always this question of, first of all, do we need to build it? What problem does it solve? Could it be done with existing tech? Could it be done with DMVPN, with SD-WAN, with MPLS VPN, with SRv6, with all these different things? And you would get the answer of, yeah, kinda, but not really.
Mm-hmm.
It requires a lot of stitching together that no one really is willing to do, but it could be done. So that's the technical. And then the moment you'd be like, okay, if we even try to create a proposal for a customer, our licensing model will kill us. We have no way to do business with someone without them going, I can't make heads or tails of this.
Mm-hmm.
What is this SRv6 license under the SP program, whereas my SD-WAN license is a different license, whereas my security license is a different license, and then I have users and seat-based and capacity-based. How do I rationalize any of it?
Mm-hmm.
This is why I so fundamentally say it's not just a technical thing. It's a business and technical thing. The business is an outcome we want. We don't want to have to figure out how to stitch together new data centers each time. When agentic workloads come online, we want them to be able to have ephemeral connectivity and have a commercial model that facilitates that. The analogy I'll draw for you here, because sometimes this can be esoteric for people who are not in the networking know-how. For the longest time, we had SMS text messaging and we had anytime minutes and those text bundles we would buy. Technically, you could text anyone on Earth. We really didn't need to create the iMessages, the WhatsApps, the Signals, all these different messengers that we ended up getting. But there was a problem. The commercial model around text messaging was broken. Everybody hated it.
Mm-hmm.
Kids, if they've used up the plan, the parents would be losing it. Like, what happened to all the minutes and the data on the plan? Now, why are we paying these overages? There's a business problem. You could have made the argument we never needed to leave text messaging. It was always there. The evolution is driven by the outcome we want. WhatsApp was beautiful because it made it easy. You didn't have to worry about BlackBerry Messenger, I suppose, gets a lot of the credit to lead the way, is around, it was on data. And you didn't have to think about individual text message rates. You didn't have to think about contracts. You didn't have the limits. And you could message anyone. That outcome drove technology evolution. We were finally able to move away from all of that. We still use text. It didn't go away. But now it's much more oriented to the outcome we actually care about.
It's an interesting analogy. Let's talk about this, okay? WhatsApp specifically starts and blows up internationally, not because of technology. I mean, it was more user-friendly. You could say that. You can argue it. They did a beautiful job with WhatsApp, right? Still to this day, it's a beautiful application. But the issue behind it was a old business trying to extract old business revenue out of technology, right? And the joke about SMS specifically was SMS is a byproduct technically of what you need to have in order to run a cell phone, a cellular network. It wasn't some product that they had to go out and buy and develop and exist. It was already there. And even more frustratingly to anybody in the know is it was free for them to run SMS. But then somebody goes and looks at it and says, hey, here's something that people want to do. We can extract money out of this, generate value for ourselves, and we can squeeze until finally somebody figures out how to bypass us completely and then completely eradicate our value, right? And, so to apply that to networking is also, I mean, it's like this constant thing, right? And I end up in this conversation weekly where people talk about, and we've been tracking for a long time, what's the actual cost of a circuit, like not in a data center. Well, we track that too, but let's say delivered to an office, and that trend goes one direction, and people freak out of like, oh, it's getting so cheap, and there's no value in this thing anymore. And I'm really sorry that you feel like a gig E circuit has gotten too cheap for you to make any money selling, but we're planning for 1.6 terabit Ethernet in a heartbeat, right? It's a heartbeat away, and 3.2 terabit Ethernet is right behind that as well, right? So
exactly. If you make it easier, people will consume more. People want more. People want to be enabled more to do more things. They want to feel more empowered to make better decisions, faster decisions, to change their lives in the way they would like to, both at an individual level as well as at a corporate level. All those things are true. And this is where so much of networking is particularly painful, because infrastructure is such a hard road to go down. You feel trapped sometimes that change doesn't happen as fast as it does in other segments. You see the application space, you see the AI space, you're just like, man, that transforms constantly and so fast, and new things come out all the time. Whereas, why does infrastructure take forever to see that kind of evolution? So that I think is a natural. We all become a little bit sad and upset if we stay in infrastructure that long, because we get a little bit jaded and cynical. But it also forces some of us to go, if we really focus on the outcomes that people want, there is a way to do transformation. We have some incredible tech in our space. We've been building some incredible things for a very long time. We have fiber literally covering the entire Earth. We've laid cables in the oceans. We have satellite internet basically everywhere now. We've done incredible things. We should take pride in it and be optimistic, but somehow find a way to get out of our own way of the old business models and think about delivering value.
So, I mean, are we, okay, business problem, right? Contractual issues.
Absolutely.
Networking talent issues. Operational issues, right? Like three, I think those are the three primary buckets we keep talking about. How much of this is solving which one of those buckets, right? Like, is NAS really about solving a business contractual relationship more than it is about who's operating it and responsible for the operations? Or, I mean, it's crazy. People coming into the space they're carrying the title of like network engineer, and you get into conversations with them and they have no idea what's going on under the hood. And you're like, okay, great. I'm really scared for this company that you're working for. I mean, they're not to say that they're not doing a good job and really trying to move the needle forward, but like the skill set. I mean, I feel like a COBOL dinosaur. It's like I know how to configure RIP at this point, and like nobody ever wants to run RIP.
That's true,
right? But like and for my Cisco fans, like I mean, I can remember doing EIGRP unnumbered, which is probably a horrible idea when you actually take it apart. But you know what I mean, like that. Like hiding the awareness of complexity behind a screen that then people don't understand what's going on underneath the hood. Like I'm never really sure if this is a good thing or a bad thing.
I think with network as a service, we have to think about three things that it has to solve. One is definitely the contractual model. It has to make commerce easier. And we have to find a way to rip out some of the older ways to find a better way to do this, just to address the world we're in. So that goes without saying. When we get into the build and operate aspects, we have to recognize the talent is being pulled in other directions as well. We have new libraries, new SDKs, new ways of developing applications, new ways of thinking about data structures. That is happening. We don't want networking to be just this alien thing that no one really ever touches. And I don't think that's going to happen, but we have to move along with it as well. We also have a tendency to be very nostalgic. We love talking about RIP, ISIS.
Oh, geez. Yeah. OSPF.
OSPF.
Yeah. I mean,
get somebody talking about Dijkstra's algorithm. It's just like,
you're going deep. Okay.
But those are the things, right? We have a tendency to really love the glory days. Even, I mean, I haven't been around forever, but even now, the tendency to want to talk about what happened with SD-WAN and SDN and NSX and all the, there is a lot of look back because it was such hard work to build in the first place. You couldn't build it overnight. It wasn't like social media. It has those elements where we have to think about the future around how do we solve for future talent too? How do we speak networking language to that?
Well, the question, the point is, are we continuously solving the same problem? Have we actually solved the original problem? Or are we just inventing a new way to solve the problem that was already solved, but then was solved again, but was solved again? And then for somebody buying it, they're just like, oh, this is just a new thing I have to buy to solve the problem that I still haven't solved with the other thing.
This is a fun. I think this could easily be a tangent because it goes in.
We're on it. Yeah,
it goes in two directions. One, I suppose, in one way, I would say the problem space shifts, the workloads, the applications, those kinds of things shift. So you do end up needing to have to evolve. The counter argument is time is a flat circle. Nothing really changes. We're solving the same problem since creating the wheel or discovering fire.
Right.
We still have energy problems. We still have heating, cooling problems. We still have housing problems. We still, in many ways, nothing ever changes. Because ultimately, that's the human condition. We live, we work, we try to provide for ourselves and our families, try to connect with other people, and then we die. So in many ways, so much of everything is just tied in that loop. But that can go into a whole other track. But that's why I think so much of it is reflected in the things we create, the things we build, and how they interact with the world. Right now, we're in the AI hype, right? Everything, everywhere is AI. But we've been talking about AI for a long time, and the goalpost on what constitutes AI keeps shifting. I suppose you could have said we had AI when Turing made his machine. It figured things. I mean, automation, the sheer amount of automation we've had and the things that it can do. Would that not be considered AI by a different measure? So the goalposts move. If we think about what it's solving, okay, an AI now is building PowerPoints and Excels. Sure. I mean, we've been doing a lot of
hallucinating along the way.
Exactly. We've been doing a lot of things. You know, broadly speaking, the big context, you might say, yeah, it's the same stuff just over and over and over in just different forms. But in the micro, in the moment, the work has changed. Our day-to-day experience of it has changed. And so the solutions that we need for it must change.
You open this door. I'm going to have fun with this. Okay. You use the word AI hype. My parallel to this in industry is 5G and 5G hype. And you have wireless providers that come to market and say, hey, we've got this thing called 5G. And you're like, well, what is it actually? And like, what they claim is 5G isn't 5G by any measure of the world, right? But now you've got, I mean, I don't know, a decade of marketing around 5G being the second coming, and it's going to solve all these things, and it's going to do all this different stuff. But they've been trying to sell this story really to the street. And instead of the story just being like, hey, we just upgraded our network, it's faster now, you should get it because it's cool and it's faster and you want faster. It's like, oh, we're going to empower this theoretical nonsensical, we hired the digital prophet, guy, and he came up with this crazy idea, on his psychedelic trip one night, but there's no connection to an actual underlying problem, right? So now we have this push nonstop of like 5G. And I'm surprised it hasn't turned into 6G yet, because we're due for.
I think you probably weren't in Barcelona this year.
Well, I've actually tried to tune all this out, right? And not to say, I mean, don't get me wrong. Steve Jobs said this great. If you ask somebody what they want, they say they want more. They want it faster. Technology exists to elevate the human condition. I believe in that. That's my core thing. We always want life to be better. Faster network is always better. But AI as a hype cycle connecting to everything that's being labeled onto AI, and in your world specifically around network and data transference, right? Really, what is a network? It's just moving data from point A to point B. AI isn't driving this massive, the average endpoint needs to have 10 gig of network anymore. Most AI sessions are small. They're text. Anyway, in any cases, I think I see a lot of enterprises probably driving down their overall data consumption because of how they're interacting with the network.
That's an interesting. I think the jury's still out on what enterprise is doing with AI. I think that's
Right.
still TBD on what's going to happen there. With network, I think there is an important distinction to make between network and AI and sort of the hype. And I agree with you, not landing into making ludicrous promises of what network will do here. Fundamentally, network is a foundational element. And when we think about the outcome, from a business outcome as a tangible thing that people can go, I understand this. There is an X amount of data in the world, whether it's in the clouds or inside the enterprises. We have a certain amount of data center capacity and power to power them up. Our grid does require distribution, so we are going to move compute around. And network is our way of connecting all these things together. Now, network still is today what it was back then, which is move from point A to point B. That's what it is. That's what its purpose is. It can't make promises of, oh, it'll change your entire workflow or somehow do, I don't even know what promises these days are made on these things. It's not going to cure cancer. It's not going to do any of those things. It's really about the movement of data. And can I move it on demand to where I need it to for the things that I need to do? That's really what network should claim to solve.
So now we've got competing moat issues.
Mm-hmm.
Data is the moat for most cloud environments. And and I'll say why, right? AWS getting data moving data around inside of AWS or getting data out of AWS until you actually go and say, how much does it cost to take storing data in S3?
Right.
Super efficient.
Yep.
Doesn't cost you a lot. Putting data into S3, super efficient. Doesn't cost you a lot. Taking your data out of S3 and sending it somewhere that is not AWS, hold on now, very expensive. And going through enough business cases with clients about looking for a different operational structure for their cloud platforms, whether they're so many different permutations of that, but getting to the end of it and actually looking at a spreadsheet and being like, it is going to be very financially painful for you to actually pull this off and to take this out of this environment. And then all of a sudden another contract issue kicks in because you find out there's a committed capacity contract in play, and then you're like, oh, we can't do this. Like, it's not. So when we talk about like enterprise drivers, who knows what the actual real percentage of compute and capacity that's still in some sort of like on-premise or what looks like on-premise for that enterprise versus what's already shifted to a cloud. And in my version of the cloud also means data centers. Like the enterprise has it in a data center. If you're in a data center, getting capacity quickly, I mean, you still have to deal with contracts, you have to deal with cross connects, you have to deal with some other procurement rules, and there's stupid stuff you have to go through. But to say, if you're in a data center, I want 1 gig, 10 gig, 100 gig, 400 gig, 4 by 400 gig network circuits, relatively simplistic problem to solve.
Yep.
I want to talk about capacity planning next, but if you're, I don't even know what the edge is anymore, but like if you're not in a data center, let's just use that phrase. If you're not in a data center, because all clouds are in data centers, if you're not in a data center, delivery and installation becomes very complicated, right? And so then is NAS solving, so then you look at it, it's like, okay, are we solving the data center problem, the capacity problem, the interconnection problem, the fact that my DevOps team is now in charge of doing all this stuff, and they want an API to go say, hey, I want to talk between these two boxes, which, I mean, that in and of itself, I'm not saying it's not a viable, valuable thing, right? But we still have this edge issue, which is I need capacity now. Like this building that we're sitting in is fantastic, except it doesn't have any fiber pulled into it yet. Why? Because it's small, so it doesn't fit any financial model for anybody to do the expense of trenching fiber. Because guess what? It's really expensive to trench fiber, right? And that's so like where does the hype cycle for AI actually intersect now with these things? Because where that data actually sits, we have this data that we want to do something with. We want to interact with it. We have an agentic flow. We need to have we have RAG that we want to run against it. We want to train a model with it. We want to whatever, right? How does that overlay with all this?
So if we keep the three sort of premises that I keep alluding to with network as a service, you've got the business contract aspect, the engineering, the effort to build it, and then the operational to keep it going. With NAS, in particular, when we look at all this, how does the AI hype cycle intersect with this? Putting aside what people are using AI for, I think first, people want to have that recognition of commercial contracts around, if I don't need a 3-year commitment with Equinix on this port going into AWS, I shouldn't have to have that. So there is that contractual element of, I want flexibility to get capacity on demand but not be locked in. So that's that commercial element. AI is definitely accelerating that because people have a lot of variability in their consumption. A lot of the companies, everyone wants to think line goes up. Not necessarily. A lot of people are rationalizing going, oh, we don't actually use that much, but I have this long-term contract that I'm stuck in. I need contractual advantages. NAS is meant to be one of the vehicles for that. That's one. In terms of the build, right, from a technical standpoint, what does this enable? To give an example of the problem that you described, you have no fiber in the building because no one can make the business case to build fiber to the building. Now imagine someone goes, I have spare rack space in the building. I could put in a bunch of GPUs here and I could rent them out because they have spare power and they know there's demand in the market. But now they're like, well, I have spare GPU. Number one, is there a marketplace I can list this on so I can make money off of it? And number two, how is it going to connect into the people that need to use that GPU on demand? This is where the NAS build overlaps with AI, where now if I have some spare rack space, which, I do, I'll put a couple of H200s, list GPU on a marketplace, and I know how to do networking to connect people into it.
No big deal. I'll just go out and get a couple H200s and just run. Hey, honey, we're not using the garage anymore.
It's true, because it pays the mortgage.
Oh, geez.
So it's almost, and it's laughable for sure. It's entertaining. But we have precedents on how this was done. Crypto, whether you have good feelings or bad feelings about it, literally what happened there. You started buying a bunch of NVIDIA to run mining rigs, and because the crypto landscape had its own infrastructure to deal with the cryptography and the tokens and the blockchain and everything else, they didn't have to really worry about the networking and security issues in the same way that we have to, where our data is structured and unstructured, all kinds of things over the last 30, 40 years, very sensitive, high risk. We have to really be conscious about it. So there is a very ample appetite in the market to have more distributed access because GPU is hard to get and power is harder to get still. So if you can get it anywhere, there's demand for that. And there's latent demand that is going to build. I don't necessarily put too much stock into edge computing yet. It still remains to be seen what local inferencing will happen and things like that. But it is interesting to see that people are willing to list it on a marketplace and there are people who are willing to buy. So putting aside all the hype, there are willing sellers and there are willing buyers. And if there's a marketplace to be made for it, there is money to be made for it.
Right.
And then finally, you get to the operational layer. Networking is not trivial. There's no magic AI that will take care of all networking. And there's it's not even on the hype side. There's a philosophical reason for it. Networking requires such determinism. You can't guess your way. We need, we all get angry if, a hop changes along the way. Okay, our telemetry told us, we call them man-in-the-middle attacks. We call them BGP route hijacking. We have bad words for things when they happen non-deterministically. This is why on the network side, what's actually difficult is our engineers won't have less to do or that we will need less network engineers. We actually need more network engineers. We have a giant problem of increasing complexity and we need a significant amount of expertise and a lot of hard work to go into it. This is where I think NAS intersects with the AI hype cycle. It isn't AI itself. It's not going to magically do things. It's a very disciplined area. We need to solve the business problem. We need to build for the fact that there is a market where people want to buy and sell compute in a distributed fashion, and that it has to be operationalized by people who have expertise. Because you may have the expertise, but most of the people in this building don't. And if they have spare compute or spare power, or like the landlord goes, I don't even need to tell my tenants that I'm going to, make more money off of the GPU.
Oh, jeez.
It's happening. We're seeing companies whose entire business model was one thing, and now they are in the GPU data center business. I don't know if you saw, there's a shoe company that's now an AI company, but it's ridiculous.
I'm sorry. That anybody who put money into that just deserves what's coming. I don't know what else to say, right? Like, it's, that was spectacular.
It's ridiculous.
This is the business case, right?
Mm-hmm.
Why do I need to go out and sign a 3-year contract or a 5-year contract? I mean, in some cases, right, what you're really doing is you're helping amortize cost out over a fixed duration of time, and you're giving somebody, an annuity on their investment dollars, right? Mm-hmm. I mean, this stuff is really not complex to figure out. If it's cost $10,000 to do the construction and $5,000 in hardware, you want to make you need an X% return over that time plus whatever your financing charge was, and the financial model makes it's really simplistic. Oh, and then you end up with an asset that's a 20-year asset delivered to a location, and you can make additional marginal revenue off of it, which is great. But, fiber is very expensive to put in the ground and wonderful once you own it, right?
Yep.
But a lot of what you're talking about really just comes down to an innovator's dilemma.
Yes.
Right? Where all of these companies, in theory, have the ability at any time to go and flip their business model upside down and, and deal with whatever the fallout is from it with their existing customer base. But, and a new entrant can come in without that risk and overhang and say, hey, we're going to do this differently. How big does the market have to get for the entrant before the incumbent goes, oh, we either need to buy you and take you out of the market, we want to buy you and, use you against our competitors, or we now see a strategic fit, or heck, we just need to change our business model because telling a customer you have to sign a X-year deal in order to get this benign thing no longer makes sense anymore.
I think it's not even a question of how big the market has to be. The market is already substantially big, especially when you deal with infrastructure.
How big the market, like what percentage of the new entrant?
It still doesn't change anything. It's when I look at, for the large entities to have to change their business model, I think in the history of at least the last 30 years, I would say Microsoft's the only one.
Yeah.
The only one. We can't really call IBM a huge success based on what they did. Microsoft's literally the only one.
I mean, that transformation's bonkers.
Exactly. They made the business model change. They made the change to do these things and accept the risk, and they've been rewarded for it, right? They've done incredibly well from where they were because of that evolution. When I look at everything else, if we put them aside for a moment, the business models restrict people so much that they're not able to do it. Fundamentally, you could talk about the fact that every networking company, from Arista to us, didn't really need to exist if Cisco would have just done it. Tell me I'm wrong.
Oh my goodness. No, but I mean, look, we're in the U.S. I love capitalism, right? Because this is it in its purest form. Like, you're not doing it, somebody else can do it. They can make a ton of money. They force you to change, right? It's good for the end user. It's good for me. I want competition.
Absolutely.
The more the merrier. Like the whole government regulation, market fixing, for insurance makes me crazy because it's okay, create some guardrails, but let anybody come in.
Exactly. If there was competition, we would have an incentive.
Yeah.
We would have the opportunity to go, oh, we have a way to solve insurance slightly better. And you could do that. Same with it. That's what's propelled networking and network infrastructure is the incumbents become so large, their business models become so entrenched that it becomes painful, and the customer, and there's market demand for, can you make it easier? Can you adapt to the new outcomes that we want?
Well, the other issue, with the Cisco is they have to build a box that can be used by everybody. Like that router, same thing with like server hardware in a data center. We talk about it, you go back and you're like, oh, the average data center is horribly inefficient. PUE is terrible. Heat loss is terrible. Efficiency on a node is terrible. And it's like, why? Well, you look at the actual architecture of the actual physical server. You're like, how many different voltages does the backplane have to support? Google makes a box. It's all the same voltage. It plugs straight in. There's nothing going on with it. Very simplistic architecture. Their data centers are more efficient, right? But Dell has to support every enterprise on the planet with that box. And Cisco, right, has to build a box that supports lots of different use cases. Like there is a problem there, right?
There is. And I think that's the problem that we put ourselves into as we get, bigger and bigger as enterprises get, is this is why a new entrant can come in and do the things that it needs to, which is it says, we aren't going to try and do everything. We are going to do that thing, and we're going to do that really well. For us as a new entrant, this is like my second go around in terms of a startup life. It's the case of, I don't have to solve everything. And trying to solve everything is what cripples when you are the big company. A box doesn't have to be designed such that it goes into a data center as well as a U.S. warship. Granted, you have contracts for both, but that you can't design everything that way. Imagine if every car was designed precisely that it could be run the same way everywhere. We would have no diversity. It's that case of you can't let your business model dictate what customer outcomes are. The customer outcome should dictate what your business model is. They want the solution. You have to construct it a certain way. Otherwise, we end up in the situation we do where everybody goes, why do I have this chassis that has all these slots and I have to pay for all of these things? I don't even know what I use it for. And if that's the more complex side, you go to the simpler side, there are so many customers who ask themselves, why do I have this Equinix Cross Connect? And what am I doing with that? The answer is no one knows.
This show exists because of what we do at itbroker.com. If you're in the middle of a real tech decision right now, new technology, vendor selection, a contract that doesn't feel right, an M&A event that just landed on your lap, and so on, we help buyers like you get it right. Independent strategy, sourcing, and contract negotiation. No kickbacks, no sales quotas, just someone in your corner. Schedule a call at itbroker.com. Back to the episode. Oh my goodness. Okay, so see, there's a so. Consolidation and bundling, right? We start in technology and you have, I hate these terms, right? Like best in breed, whatever box service. And that company will then go and do, TAM expansion or SAM, technically SAM, right? Where they want to address more of the market. Sure. So how do you do that? Well, you get pushed into doing additional things. What do we see in the networking, like the physical box manufacturers? Well, they had a physical box and they had a physical firewall, and now, they have to go out and they have to, be an EDR and then have this and then be an XDR and then have this and this and this and right. And then you end up with this thing where you're like, okay, now I have this behemoth behind me. Same thing with this, with the carriers. Carriers have to provide and operate, SD-WAN, firewall. Now we call it SSE and SASE.
Yep.
You guys have the same pressure here, right?
We do.
Buyers want to reduce operational complexity and the amount of vendors that they're dealing with. But how do you layer in, it's not SASE really, it's SSE by definition, even though it's PAT, it's not NAT, people. It's not NAT, it's really PAT. I just can't help myself, right? But that drives, is that mission complementary? Is it mandatory just because this is what the market demands at this point, or are they competing with each other to some degree?
The situation where what the market demands and your philosophy aligns is when things are good. When they're in conflict, that's when you have the problem. So for example, for us, it's always been a case of our fundamental principle is we can never have possession of the customer data. We can't have payload. We can't see it. We can't have the encryption keys. It's a confidentiality, privacy-driven motto. So if the market demands a bunch of things from us, as long as it doesn't break that principle, we can build it. And it is fairly straightforward for us to build it. But when someone comes in and says, actually, I need you to basically be the equivalent of a TLS proxy and look at everything. Well, now we go, that is a problem for us. This is where having clear understanding of what your core principles are and how you can service the market and can you hold that line becomes important. If you end up being with your principle is, we'll do anything, then the market will push you in 1,000 different directions. Then you will have these problems of building these God boxes that are supposed to do everything, and then they end up doing nothing really that well. And everybody just gets upset. And then over years, it's the same thing. It's a vicious cycle, right? Same with SD-WAN. It's like, we had these simple lightweight boxes, but now we needed them bigger, and now they're heavier. Now they have all these things, and now there's an ASIC in them. And it's just like, now you can run local inference. What is this thing now? It's the same problem. And it's not just any one vendor. It's, we have to stay true to ourselves. Otherwise, we'll fall into the same trap.
So I think you, your pitch, your branding around this, what's the line? Security as a common good at no charge, I think is the actual tagline, right?
Yes, absolutely.
Now, when people hear the at no charge, come on, people are suspicious.
Yep.
Right? We've been burned in the past. So how do you walk through that then when people that response is going to be like, oh, come on, what's the catch here with this?
And so we tell them, it's just like, look, a lot of what you are being charged for is just the same SMS story. Mm-hmm. It comes with the solution. There's no added cost to build it. It's part of software. It's already there. Imagine if someone came to you and charged you, and it would be entirely possible, thank God it can't happen now. Someone came and charged you for AES 256 versus AES 128. Could have entirely been possible. And someone could have made the argument, well, this is military-grade encryption.
Oh, jeez.
All right? There's no such thing as military-grade encryption. It's just encryption.
Post-quantum. Is it post-quantum? Yeah.
Even with post-quantum encryption, right? Like, that's a particular set of algorithms. Oh, would someone charge you extra for each algorithm? It's possible. It should not be the case. Mm-hmm. With a lot of security capabilities, a lot of them are software capabilities that are already there. So much of it doesn't make sense. Why does a user seat exist for remote worker VPN? I don't understand that one.
Okay, let's play that one out, right? Mm-hmm. Which is, I have to buy something from a service provider,
yes,
right? Or a vendor, a box vendor.
Sure.
Am I buying it per megabit? Am I buying it per port? Am I buying it per theoretical total capacity, or am I buying it based on the amount of users behind it? And this is a very interesting thing, right? Because I think to your point, each one of those has a problem.
Yes.
Right? Which is like, well, how much bandwidth do you need at this office? I don't know. I need all the bandwidth.
Mm-hmm.
Okay, now pick one. And this was the most annoying thing with SD-WAN for a long time with a lot of the vendors. It was like, oh, okay, but the box supports this capacity.
Right.
Your MPLS supports this capacity. And oh, by the way, you have some sort of service that has to go through a gateway, so you don't have NAT traversal issues. That has a different price point attached to it, right? And now explain that to a financial buyer.
And that has been, I would say, when it comes to actually building the security capabilities, building the network stack, the hardest thing for us in Graphiant's journey has been navigating that contractual business landscape, where so much of the time we have to construct flexibility for customers so it can fit into their models, mm-hmm. which is, oh, you want it by capacity, by megabit per second, so it's all aggregated. You don't have to worry about users and seats. Here's this model. We'll still have people who say, actually, can you do it by user? It's like, okay, we're going to make some assumptions about what a user does. The end goal, and this has been the goal that I always wanted to get to, but I realize it's going to be hard because that itself is a transition, is this notion of tokenization, which is network and network capabilities and network capacity has the ability to be tokenized, which means eventually, not now, I suppose, in the future, we'll have the ability to say, this token entitles us to do a whole bunch of things. It gives us connectivity, it gives us capacity, it gives us security. We can min-max it in any which way we like. That would be the ideal for where NAS ends up, where I know people have misgivings about tokenization, how AI tokens and all those things are used, but it gives you that flexibility. It frees us up to construct contracts in new ways. Whereas right now, we still have to deal with is this megabit aggregate capacity? Is it user? Is it license? Is it 3-year, 5-year term? Do I lock all these things in? How do I rationalize different licensing models? For us, it's always been, can I build a philosophical layer on top of which I have the flexibility to construct it as the market demands, but it doesn't break my philosophy? So underneath the hood, it's still, I can quantify by a token level what it takes me to do all of these things. Provide you networking, provide you security, provide you all of these things. So when a customer comes to me, I don't have to walk them through tokenization. I think that was the lesson I learned, was it's still fairly complicated. Agentic systems will get it naturally. They exist in that universe. They operate on tokens. So a network token will mean nothing extra to them.
Right.
They'll be like, I totally get it. I can build an on-demand network, use this many tokens. When I've used it, I tear down the network. Done. But for enterprise, for business, it was, we have the mechanism to construct the vehicle that you like. But you should know we're not charging you extra for things that come in software. If I have the software capability to give you privacy, to give you security, why would I charge you extra for that?
Don't you run into still the same capacity planning problems? I mean,
We do. Yeah.
I mean, because, right, like you go through the cycle and it's like, okay, well, what do we need to buy here? Well, I don't know. Like, what's your budget? You know, I mean, in a lot of cases, that becomes a conversation. It's like, okay, well, how much money has already been allocated to solve this problem? And what can we get you for that? Oh, we can get you 300 meg. We can get you 2.5 gig. We can get you whatever it actually is. And then how does that capacity get increased? Oh, you're running your network at some level that you've decided. Oh, we want to run this at 60%, 70%, 80%. And you're like, hey, we're consistently at 70% with peaks up to whatever. And we need to go get more capacity, aka we need to go get more budget allocated to us to do this. But that is the purchasing cycle when we start talking about technology inside of most enterprises, which is my two least favorite words, ROI and TCO. Okay? Because trying to figure out how to justify this nebulous thing to somebody to then understand why they're spending money on it, it usually just comes from a frame of reference around this is what we're currently spending.
Right.
Right? So how does that change?
For us, a lot of what we find is we'll have two categories of customers. One is those who are really pushing the envelope, who are pushing the boundary in consumption growth. They are a whole beast unto themselves. Classical capacity planning models do not work with them. There we end up min-maxing to the nth level, but they are few and far between. They are the ones who stress us out. The vast majority, when we look at people and what they're spending, one, it's very easy to find out, more often than not, they've oversized.
Like 100% of the times.
And they're overspending on licenses that they don't know.
Also 100% of the times.
And they're spending on things they never needed to begin with, because it got packaged into the bundle at some point and it seemed like a good deal to get this extra thing at like 90% off, but you never use it. And so you end up seeing, traditionally, wherever we go, we are able to make the bold claim it's going to cost you 50, 60% less. I might be off by a few percentage points, but not by a lot. Because I'm going to look at your network and go, oh my God, you're buying 200% what you actually need. You have 28 different license tiers, 19 of which you don't need. I can package most of them up into a single thing that you aren't even going to pay for because it comes with the service. Yeah, I'm going to save you money. Like, this is not even a no-brainer. So that happens organically with bloat, because we know what happens in network infrastructure. Prices go up, things get added on, everyone has to upsell, and so over time, you have bloat in the system that has to be rectified at some point. And that gives us the in immediately.
How do you solve the edge problem? And what I mean by that is, ultimately, a company needs a circuit, a port, physically connected to your network.
Yep.
Or they need a box that can then, basically everything becomes an IPsec tunnel at some point in its life, right? a box that can connect to your network.
Yep.
So, now, you've got like this fork in the road. You can say, hey, we can support anything that supports an IPsec endpoint. And here's how you configure Cisco or Juniper or, this or that or Palo, whatever you want, right? Or here's our box that we give you, because part of the reason you're talking to us in the first place is because operational complexity, not being able to manage it, right? Like the original secret sauce of the SD-WAN.
So on that front, I think we'll get to the box because that's a longer one. For the endpoint piece, yes, the software capability is there. You can deploy it, you can connect it. If it can support IPsec, yes, it can connect in. So that's not a problem at all. Users, remote workers, all that sweet stuff. On the box front, when we started out, this would have been 2020. We were in the middle of the pandemic. And at that point in time, we were coming out of the Cisco, the HP life and everything else. And everyone's like, well, a network box has to be a specialty box, and all kinds of supply chain problems, and customers are going to worry about all these things. And we spend a good amount of time looking at hardware, looking at, okay, what if we supplied the hardware? But handling all of that hardware comes at a certain price point and all these things. And then you start to look at, well, what are the manufacturers actually manufacturing that's uncustomized? It's like, it's the same thing. Literally the same thing. The same box that Zscaler uses, that Netscope uses, it's the same box. There's nothing unique about any of these.
I might have one here on a shelf somewhere.
It's just painted.
Yeah.
Right?
Yeah.
Like I can look at them and I know who the OEM is that manufactures
Of course.
them.
Yeah.
And so it ends up being the case of, okay, so it's the same box. So we don't really have to customize this at all. Then the second question was, well, will customers want to be able to source it themselves or go through like a VAR or handle it in a different way, or do they want the vendor to provide it? And this was where this was going to be like a make or break moment for us in terms of decision making around, do we have to do the hardware ourselves? And what we found, because of all the supply chain madness that had happened, not just the pandemic, but then after the pandemic, compounded by tariffs and everything else that happened, people want to be able to source their own equipment because they want to be able to find their own best deal. They don't want to have this, we're going to buy it from you and you can charge whatever premium you want because you can claim it's a RAM shortage or it's a tariff or it's a supply chain issue. People are very sensitive to those things now. And we found less and less people saying, oh, you have to give us the box. We found more and more customers saying, just tell us what are the different certified profiles and we'll figure out who we want to source it through. We're going to get our own VAR. We're going to handle it. Or like, here's a platform we use from the Philippines. Here's one from Taiwan. Here's one made in the USA. Here's a bunch of options. We have no preference. You are free to do whatever you want. That box costs $10,000. This one costs $280. You are free to make your own choices. The software service will deliver as expected. There's no restriction on features on any of them. So even on the small end, all it will change is how much throughput you can push. And we're going to give you numbers, not hypothetical numbers, because it's not our box anymore. These are numbers of our software with all the features turned on, because that box is not our box anymore. Now we can be neutral as well between here's a Dell box, here's an HP box, here's a LANer box, here's a Silicon box, here's all these different boxes. That neutrality also helps. It also means import-export rules. It means sourcing. It means for customers in the enterprise space, they're like, this is really handy. Now we can figure out our best price point. Now we can negotiate even with you that if we're going to source our own box, then can you give me a discount here? Gives them optionality. When you think about smaller customers who just want the convenience, we're like, that's fine. Made in the USA.
Yeah.
If you want something cheaper, we'll bundle it up.
If you've never tried to import hardware in cross borders, like you just don't understand. Like
exactly.
it's just so. It is such a surprising black hole of pain the first time you have to go through it.
Absolutely.
And depending on the jurisdiction you're getting to.
It changes your view
for sure.
on equipment entirely.
Oh, we had what were two of my Brazil and Hong Kong. We had projects going on at the same time, and it was just, you're just like, okay, what do you do? You just do.
Exactly.
I had for a long time, I saw a lot of SD-WAN vendors come to market, and the core pitch, of course, became we're gonna be way cheaper than your MPLS network, and there was a lot of other stuff into that, but let's just distill it to that. But then you would see the cost model break. You would cross a certain speed, and then all of a sudden, it just didn't make financial sense anymore. Like the math broke. And of course, I'm looking at this and I understand why the math is breaking. It's like you've made infrastructure decisions as this SD-WAN provider because your team probably didn't really understand what they were doing, and you went and put it into Azure, and you've got an egress rate that you've got to deal with. Or you've done X, Y, and Z, you've done this, you've done that, and I'm looking at these things. And how, as you guys scale and you start talking about customers' data throughput scaling, right? Like a customer coming to you and saying, hey, we need 10 gig. Like 10 gig is like whatever. But a customer saying, hey, we want 400 gig in 15 different locations, very different demands.
We have an interesting challenge where, for us, the difficult part is at the very low bandwidths and then at the very high bandwidths. So the middle tends to be smooth sailing. On the very low bandwidths, it's hard because the overall revenue is so low that the level of effort is just like, okay, man, but you want to do right by the customer, and you're like, that's all they need. So that poses a challenge. On the very high end, this was, again, a big concern for us, is like, how bad will this get where somebody just like, I want multi 400 gig connections all over the world. And it was, again, that case of people tend to think they need way more than they actually do. We have a customer that is on the very high end of consumption, but even their consumption, you can start to see the patterns, which is it's US East. It's US East 1 where the consumption is. It's not all over the world.
Yeah, the internet has become Virginia.
Exactly.
Like, it's in one place now, yes.
And then you go, they might say, we need 400 gig, but you're not even crossing 10 gig in most of these places. I know. And so that made our mathematical modeling so much simpler, where we could go, we could go into a customer and say, we have the ability to multiplex, so we are not restricted to one carrier. We're going to get lots of carriers and lots of markets, but now I have optionality where I could talk to the carrier ahead of time. I'm going to get a 100 gig port, but I'm only going to light up 10 gig on this right now. And then when I need to expand, I can expand, but otherwise I can downgrade as well. Very rarely, to which I would say Virginia is the only place where we needed to have sort of an exclusion to how we adapt and build. Everywhere else, it was very predictable. And we had a significant amount of lead time where the consumptions didn't go 0 to 100 overnight. We were able to predict, and because our network design doesn't require us to be strictly tied to a single wave or a single L2 or a single L3, multiplexing options meant we could use a lot of carriers in the intermediate as capacity grew and plan accordingly. So when people say, oh, what are you doing underneath? I'm like, yeah, I'm using Equinix, I'm using Packet Fabric, I'm using Megaport, I'm using Cogent, Cox, NTT. A lot of my connections are people who migrate off of Equinix to me because they're like, you're going to provide me the same thing, but with better flexibility. And so I anticipate as these things grow, will I hit those problems, the capacity planning problems? Absolutely. I definitely will. I anticipate that, but I think that's still going to be very US-centric, and it'll still be very Virginia-centric. The data patterns are what they are. No one's moving multiple hundreds of gigs between Hong Kong and Singapore. That doesn't happen. It does in US East 1.
Yes.
And so until things are truly more distributed and that there are more data centers in the rest of the world and the data gravity has somehow moved away from Virginia, until then, I don't anticipate this being a near-term problem.
Is this another argument to separate control plane from data plane? And then, I mean, when you do that, though, I mean, to the extreme that I'm thinking about, you just shift where the cost goes, right? Because in order to do that effectively, now you have to have something that's then processor intensive,
Yes.
Doing that work, right?
And when you think about at the network layer, there's the control plane and data plane, as we think about like what the processing is. Control plane ended up consuming a lot of processing power over the years because we've bloated control plane. We have, just when you think classical IPsec VPNs, IKE, BGP, DPD, IPSLA, PFR, I could keep going. How many things are you going to process before you make a decision? That's, in human language, you'd call that cognitive fatigue. You run out of computes now. You need more compute just to think about a forwarding decision. Whereas forwarding plane is just fire off data.
Yep.
So when you simplify the control plane and you separate the control plane, you do see massive benefits from SDN. The data planes become simpler. They perform better. Even data plane features can be delivered, and they still perform really well as long as you don't bloat the control plane. And that's when, if you're really honest about the operational cost to deliver a service, it's in control plane. If you do control plane right, if you manage control plane right, your OpEx goes down, your margin improves, you deliver a much more efficient service. Because at the end of the day, data plane is just forwarding packets.
I think the majority of the carriers you rattled off, I'm not going to name names, don't actually own a network. They purchase network from other people, and they disintermediate or aggregate that network, right? So now you've got network, aggregator. I mean, you're not an aggregator, but aggregator, right? Yeah. I don't even know where I want to go with that. It's like there's so many stacks of like tiers of people. Like, let me phrase this a different way, right? For a customer, where is NAS not a good fit, right? Because now we start talking about in that stack, they could go here, they could go here, they could go here. Now I will argue, by the way, looking to the camera, I will make this point. I love all those companies, and we use them because the underlying provider is such a nightmare to work with that you can't work with them, right? And we don't ever expect the underlying to ever, they haven't fixed themselves in 30 years. They're not going to wake up tomorrow and fix themselves. Like, let's be real. So we love these other companies, and we love them for specific reasons. But, but for an operator, for a buyer, for an enterprise, where does NAS not fit? And what should they be doing differently then, right?
Where does it not fit at all? I think this is where, if we're purely talking data center network and just within data center, not necessarily a fit, just because you already know the space you're in, you know exactly what you need to do. So NAS typically I wouldn't say is the best fit there. When we talk about things that are very niche, that gets very hard as well when people start talking satellite and some of those kinds of things. Oh, you want to build a satellite mesh. I'm not so sure. Some prototype designs, but nothing that clear about how you would deliver that. How do you construct overlays on top of that, manage that in an effective way? You're still using satellite. Still vague, still needs to be resolved. I think people are thinking that Starlink might be a panacea for pretty much everything. Unlikely. Fiber in the ground is still fiber in the ground. It moves faster and does everything that much more efficiently.
Wireless companies sold off all their fiber and then just went back to buy it all back up, right?
And that cycle is vicious because then you realize the performance limitations. Yep. Fiber optic is good for a reason. All of those things are sort of outside the realm, but if we go back to what the fundamental tenet of what NAS is supposed to do is, if it makes the buying cycle easier, if it gets you that outcome that you want, and it builds this network that's simpler to operate, then it applies at all layers, which means if you are branch to cloud, it makes sense for you. If it's branch to branch, it makes sense for you. If it's cloud to cloud, it makes sense for you. If it is roll out new GPU services, it absolutely makes sense for you. If you want to consolidate contracts, it makes sense for you. There is an inherent simplification. It is not inherently tied to the hype cycle. It is tied to business value, which is you can simplify contracts, you can simplify operations. This is the big NAS driver, and it should be. NAS isn't built, in my view, on a hype tech. NAS is a consequence of having so many different techs that we have to think about how do we rationalize this. Mm-hmm. And this is where networking as a thing, and this could be controversial as a thought, is it needs to return to the carriers, and the carriers need to do right by it. Otherwise, it will end up with the hyperscalers, which is straight up monopoly, right? Then, because the enterprises won't have the expertise or depth to run it themselves. There's only a handful of enterprises that could. And even they don't want to. If it was up to them, it would be run by the carriers. That's why we had MPLS VPNs run by carriers for so long. Everybody wants that to be the model. We don't have it. The hyperscalers make inroads all the time because they will take everything if they can. And you know what? More power to them if we don't stand up and find a different model. But having seen, especially if you're a networking person, having seen how networks are built inside the cloud, you do not want that to happen. They're terrible. The layers of constructs, your favorite NAT pat, good God. I don't know what is it inside the cloud environments. It's neither NAT nor pat. I don't know what it is. There's no broadcast domain. What? There's no L2? Okay. We've all these VPC and inter-VPC constructs. Why?
Well, if we actually had real competition between the cloud, the hyperscalers, it would be different.
It would be very different.
But, the average enterprise does not understand that as soon as they scale to any size with any one of these things, multi-cloud is a marketing myth, right? Like it's something you tell your people to say we have business continuity, dealt with and, risk concentration. But let's be real. There is no such thing as multi-cloud.
And I think if you look at from the network as a service, we do it, some of the others do it, and, Alkira, big move for them on that space as well. The business case was, people are forced to use the multiple clouds. And they have to use them. Yeah. The network has to stitch them together. There's nothing universally magical or any reason to go multi-cloud other than you have ended up going multi-cloud. Because they're all the same.
You have investors, which means you have one of like 4 or 5 possible outcomes at this point, right? We don't have to list them off, but with Alkira coming off the market, and now this conversation is going to change a little bit for you, right? Because this thing that was always going to happen now is front and center for people again. First off, when you start talking about like normal network purchasing, 3 to 5 year contracts, capital deployment, support overlay on top of that. The first thing I would say to you is like, how are you fundamentally different in those worlds for a buyer? And the second part is, like you're not transacting tomorrow. At least if you were, you would not tell me. So I'm not even going to ask. But how does that change the conversation of what they're thinking about and how they're evaluating? Like, I don't care how big you are. There's always a potential of something happening, right? So how does that play into the sales cycle for you?
So I'll tackle it in 3 ways. One is sort of how we do the things we do and what it does from an outlook standpoint for us. And then looking at what we're seeing from a market standpoint, and then broadly where we would ideally like to be. The way we operate, because we don't have a heavy dependence on the native cloud constructs, our costs aren't linear. We actually, and this is why the bandwidth capacity planning aspect was so much more around finding the right math around what capacity we need to make the associated revenues and so on. So we don't have linear cost growth. Our costs stay flat until we need to make a substantial investment to grow aggressively. So that gives us a lot of leverage from a strategic planning standpoint. If AWS costs go up tomorrow, ours don't. We, in fact, have now more incentive to go to customers. We can provide you better arbitrage and network egress costs and things of that nature. So there's advantages for us. It gives us the ability to look ahead and think about where we want to partner and how we want to partner, because our footprint is very low cost to operationalize. This is why GPU as a service is so interesting to me. Beyond just the hyperscalers and beyond the big data centers, I'm seeing demand of, I have GPU and I want to connect it. So there's a lot of acceleration on that front. We see sovereign demands around, we don't want to be in US East 1.
Yep.
How do we make sure that our entire nation state isn't bound up in Virginia?
Mm-hmm.
Because at that point in time, we may as well say the rest of the world doesn't exist. Everything exists in Virginia. So there's those elements that are accelerating a lot of things for us. You've got post-quantum encryption, you've got all these kinds of elements, but fundamentally it comes down to you still have enterprises that want business outcome. You have sovereignty aspects that people are thinking about. People are worried about what happens to costs. Then we look at sort of the market events. I think for a long time, because NAS is not glamorous, not in the AI way, it is a market.
Yep.
It has a lot of different products and vendors in it, and it provides services and is a substantially large TAM, but it's a market that moves at its own pace.
Mm-hmm.
And so everyone's just, all right, same old, business continues as usual, no need to worry. I think the event with Lumen acquiring has a triggering event. And from the sheer number of phone calls and flights I've had to take in the last little while, yes.
Mm-hmm.
Because I think implicitly a lot of people just assumed that even the NAS vendors were going to get picked up by the large networking vendors.
Mm-hmm.
Everyone just assumed, oh, the vendors will pick it up.
Yep.
No one really thought that the carriers are going to be looking at it to pick it up. And so that, I think, is accelerating a lot of different kinds of conversations about if carriers are going to pick this up before the vendors take it and raise the rates and do everything else, this could be a perfect opportunity for the carriers to take it, especially if they're being asked to do sovereignty, if they're being asked to do data controls.
I'm going to say it. You don't have to answer it. This is it's Lumen buying, right? It depressures their cost model from what they have to go out and buy.
Yes.
You know, big Viptela, a lot of Fortinet, lots of other hardware in there. In theory, how much of that can they now replace with a cost that has, zero marginal cost for them in order to operate? That's very interesting. Changes their operational,
Absolutely.
Changes their margin, their cost purchasing, operational overhead. They're selling off a lot of their network. Can they displace what they've sold off with a different service? There's lots of things there. And you basically just kind of spelled it out. It makes it very interesting now also for you because, you could go back to Cisco again in the future. Who knows, right? Or, another carrier comes in. And this is, it's interesting. Like
Yes.
that's interesting outcomes. Now, from a buyer, from a customer standpoint, so from a vendor standpoint, I've been on both sides of this table, so I understand it, right? From a vendor, you want really long contracts that are very predictable, that are annuity, and you trade margin with that contract duration, annuity, and predictability for your business. From a buyer, I want a zero duration contract with 100% certainty of cost structure going into infinite into the future, right? And with no changes ever allowed.
Yeah.
How do you balance those two?
I think this is where we give customers that flexibility because exactly as you described, I think this is the advantage of having a sophisticated buyer, especially when it comes to network infrastructure. Most of the time, they are sophisticated buyers. They understand the trade-off.
Mm-hmm.
If you stay pay-as-you-go, you're not going to get the lock-in that you want, but you'll have the flexibility. If you want to lock it in, you can lock it in. We, I think, philosophically would prefer the dynamic model. I know people would find that odd. It's like, why wouldn't you want long-term contracts? For me, it comes back to infrastructure is a low churn environment. No one's ripping out their network every 2 weeks.
Mm-hmm.
I'm okay if they do it month by month. I'm okay with that. I would rather they have the flexibility. Now, granted, that gives me some additional leverage, which means if the price goes up, it goes up. But it goes back to that principle. Infrastructure is serious business. It doesn't get replaced every 2 weeks. Give people the flexibility. If they consume it and they like it, they will grow it. If you didn't do it right by them, they're going to find a way to get out anyway. Mm-hmm. That long-term contract is just a clock. That doesn't change anything.
For me, and I counsel, providers in our portfolio all the time. It's like if you don't force people to make decisions with their infrastructure, a lot of times they won't make a decision with their infrastructure, right? And so like, what are you actually trying? Oh, you're trying to like shove this like renewal and making it really hostile down somebody's throat. And then what do? They go, well, do we actually need this? Do we have it the right size? Is there a competitor? What's going on? And all this stuff just goes, like everything just gets cheaper, especially, every 2 to 3 years, we have a new Ethernet standard that hits the market. Everything gets faster.
Yep.
Networks have to go through replacement cycles, cost them a lot of money, but they, capacity goes through the roof. So the incremental cost of that, unit goes down a lot. This is fun, right? So from a buyer standpoint, your provider was just purchased. Does this elicit a response of, I need to go out and sign the longest contract I can stomach right now to have predictability through this acquisition process? Or do I want to figure out how to have the shortest possible duration, not re-sign, wait and see what happens with this thing, accept the impending increase in cost, but like kind of like wait it out and then make a decision?
I think this is where this is a tricky one, right? Where on the acquisition side, if it had been a vendor acquirer, I'd have said, get your long-term contract right now.
Because you know the playbook.
Exactly.
Yep.
It's going to go up so much. For the carrier, there's a delicate balance because they are an operator. And if a lot of what they provide is commoditized in lots of different ways, it's not so difficult to switch carriers if you set your mind to it. It's not that hard. There's enough aggregators who will switch you from AT&T to Verizon to Lumen easily. So I think there's reason to believe that will still be a good balance. I couldn't counsel one way or the other. I'm much more inclined, just because of the nature of how industry and business and everything is changing these days, to be careful, to do more of the on-demand as you go. Because you don't know what's going to happen in the next 6 months or a year. There's too much volatility at this point. That's why I'm much more an advocate for pay as you go, pay as you grow. See what's right for your business. 3 months later, something might change. And you might need to pull back dramatically. Or you might need to grow dramatically. Right now, everything that's happening, there's just so much volatility. I worry about getting into too many long-term contracts.
Does this business support independence going forward, or are we looking at the same thing in consumer packaged goods, where like the goal is to get big enough that somebody wants to come buy you because they have a more efficient distribution structure, right? Like, Dollar Shave Club, right? They go out and they sell, and phenomenal outcome for them. But what was the next problem that they had to face was distribution. And they're like, I think it was Procter and Gamble can come in and just say, hey, we're going to buy you for $1 billion. And we're going to put you on every shelf on the planet. And,
right.
The scenario of like HP, Broadcom, Oracle, all these like tech holding companies, as you kind of put it. Do independents survive in this world? Do we see people actually staying, here, or has everything become owned by the hyperscaler or owned by the conglomerate?
So I think there is, in the current market state, it's hard.
Yeah.
Because there's such a tilt towards ridiculously large valuations, large growth multiples, and then all the power and capital being concentrated in that space. It's made it harder to stay competitive and be smaller for a very long duration. It's definitely harder. I think there is going to be a reset where, because so much will end up being concentrated here, people will want optionality because those costs will go up. I think those costs have been subsidized for a very long time, but the monopolies are kicking in. We've seen AWS bill, and the shock of AWS bills now is a common theme. It took, 10 years for Uber to start becoming so unaffordable that we're now back to taxis? It happens. There's a cycle. I don't know how fast it is and how long these subsidies last, but there is a cycle to it because it just becomes too expensive to do what they're doing. So competition will find a way. And it goes back to, this is still a very competitive market. There is always opportunity to be more efficient, to do things differently, to create new value. And there will be willing buyers for it because, again, they are competitive as well in their markets. So I don't worry about the U.S. market. Internationally, yes, there's other kinds of problems. But in the U.S., I think there is possibilities. Now, for us, when I look ahead, this is one of the reasons when we created Graphiant and the approach to network as a service, we always wanted to create a path to standardization. This was not meant to be a proprietary protocol or proprietary system. So that it creates the avenue where, if given us the opportunity and the time, with the carriers, with the ecosystem, this would become a standard. Which means anybody could do this. Everyone could do this. It's taking, instead of MPLS being a product, MPLS being a protocol, the idea here, NAS goes back as well as a protocol, which means everyone can do this. If you want to offer an easy way to transact, with a network that can be built on demand, that is easy to operate, that should be available to all.
I love startups. They're intoxicating. There's a certain like addictive quality to it, right? But if you've been through the process of going 0 to 1, 1 to 10, acquisition, exit, whatever, there's a certain toll that goes on top of that as well.
Yes.
So, correct my pronunciation, but Khalid Raza, you guys had this idea with Viptela.
Yep.
You build Viptela. You sell Viptela. You go through integration of Viptela. You're dealing with. By the way, I'm a Cisco guy. I love Cisco, right? But I can call Cisco the Borg. When the ASRs hit, it was like the coolest thing that ever happened in my life. It was like, oh man, this is so awesome, right? But this just wasn't like startup junkie, going in and looking for another hit. When Graphiant was founded, like what was the this is why we're going to do this again, and what was that conversation with him?
This is where, and Khalid and I were experiencing two different things. He's always been the visionary. He's always looking ahead. He's always like 10 years ahead of where things are going to be. And at that point in time, he's just like, look, systems are getting disaggregated. This is not just a one data center to 10 data centers. Data is getting disaggregated. Everybody thinks it's getting concentrated. It's not. It's everywhere. And it is moving everywhere. And we're still trying to stitch these point-to-point VPNs together, and we're bloating state to the point that you don't actually need sophisticated attackers. The vulnerabilities are in the network cores. You can do lateral movement. The state is exposed. All these concentration points are bad. We actually need to return to that principle of distributing state, removing state from the middle, enabling new security and new capabilities that allow for that more dynamic internet, like that principle of the internet. So he was very excited and very enthusiastic about what that future looks like. I was on the crisis response side of, oh my God, everything is just terrible every day. What is this? This crisis. You go from one crisis call to the next crisis call.
Sorry. Knowing Viptela installations, it's really funny. Sorry.
It would happen, right? And especially post-acquisition.
Well, it's not just Viptela. It's like, it's like Viptela and the carrier then integrating it and whatever service provider's involved, and then a customer having their own ideas of what it is. And you put those four in a room together and you stir up the pot and you're like, okay, let's have a running network.
And it was something to manage. And even the technical challenges, I would have said, if it was just technical, been fine. Mm-hmm. It's engineering, it's code, you work through the problem.
Yeah.
The business side of it was brutal. I spent more time looking at bill of materials and SKU lists, going how do I make sense of this? The customer doesn't even need this. Why are we doing this, not just to them, but to ourselves? Why is this the way it is? And it was just somebody made the statement, oh, there's an Oracle database with a SKU list somewhere and you cannot change it.
Yes.
Okay, I guess it is what it is. And so Khalid was the one advocating the most. He's like, we need a return to the telecoms. It can't just be over-the-top vendors. We need a return to making standards. We need a return to upgrading the internet. We need to return to sort of the pedigree that we once had of the 90s, of when the internet was first dramatically expanded and new standards and new protocols and new innovations happen at breathtaking speed. We want to return to that as we think about this distributed data problem. Mm-hmm. It's not about edge. It's not about cloud. It's not about AI. It's about data is distributed, and you need a better network that interacts with it. My conversations with him were always, we also need to think about the people that buy and sell this. We have to make their life easier to do commerce beyond just the network building protocols and exchanging labels and keys. That has to be delivered as a service. That has to be the transformational element. Now, granted, this is before all the AI hype had hit. We were just like, if we do this right, this is Skynet. And I was like, it was jokingly said, right? Like a network that's dynamic everywhere on demand with a distributed data system. It could come up, it could come down. Fantastic. And then everything happened. We're like, oh no, this is happening. What have we done? So there are some fun moments as well, but it is like the startup life is a madness-filled journey, without a doubt. You have these really high highs and really low lows. Every day is an intense journey. Every day, every hour. It's like 10,000 things happening all at once, and you are responsible for all of them. But there is an excitement to it that is really hard to convey. You know, people be like, you have no life. You're always working. You're always running around. You're always doing these things. Like you feel alive in a way that you don't elsewhere. It is insane. It's hard to describe to anybody what Silicon Valley does to you, but once it gets into your blood, it is impossible to get rid of.
It's intoxicating. I mean, .coms are fun. So you've been in the CEO seat for 7-8 months now. What's the change for Graphiant that the outside hasn't seen yet?
The biggest change is our go-to-market motion and how we're thinking about scaling up. There's still the transition that Khaled made and the board made was around, we need to start thinking about going beyond early stage and now into the scale-up stage, where we've got those critical customers. We've been doing crazy amounts of innovation, writing a stack in Rust so that we're memory safe from all the potential vulnerabilities. We've been doing a lot of engineering work, which is cool and exciting. But now we have to think about what that business model looks like and how do you rapidly scale up. That meant, how do we think about certain go-to-market motions? How do we think about engagement with the carriers? How do we think about standards? How do we think about government engagements, where I could tell you a lot of people are like, oh, go pitch to Air Force, DOD, all these things. I'm like, the government does not transact that way. There is a method to it, and it has its own madness. Same with the U.S. It's just like, oh, go to just all the top enterprises. Like, no, there's a motion, there's a channel that does the overwhelming amount of the heavy lift of the commerce side of it, whether they do the technical side or not. That is where the focus has to be. It's still cool to build stuff, but that is the side of business that has to get done. So that's been the biggest focus on how do we make it simpler to transact? How do we make it simpler to onboard channel partners who can accelerate the velocity? How do we make it more easy to fit into carriers' existing contractual models? As much as we've talked about all the problems with it, they exist and we have to fit into them. And so contractual work, working with the carriers, structuring business so that we can scale up rapidly. That has been the biggest focus since I took over.
It's a fun challenge. It's a fun challenge. I mean, scaling, going from inception to product to then scale, like very radically different issues you start dealing with, and all equally important, but very, very different.
Yes,
because then of course you're at the point now where people, I have to imagine, are breaking you in ways that you guys wouldn't have expected, right? Because it's like, oh, we decided to do this with it. And you're like, oh, I didn't know it. That's weird. Like, why are you trying to do that? And it broke. And you're like, okay, well, it's not weird that it broke because it wasn't, but like, that's interesting that you're trying to do that with that now, and you get into those kind of conversations.
Those are fun. Those are still the ones that excite me the most around, okay, you found new applications for it. Fascinating. The painful ones, the things that take up the most time, are still the contractual ones.
Oh, geez. It's like every problem is either a contract problem or a billing platform problem.
Yes.
It's like 100%. Like like
it's so much of the time we're just like, guys, we'll get into it and we'll look at the diagram and go, yeah, this can be done like in a month, but it's gonna take us 6. And so that is really, how do you shorten the cycle? How do you make it so much simpler to go, this is what that deployment model will look like. This is day one. And day one is going to give you the feel for what the next 60 days looks like. Oh, it's that simple? Yes, it's that simple. What about the transaction model? Okay, if you want to boil the ocean, you certainly can.
Mm-hmm.
Please don't. And so there's ways that we work around, okay, if you want a t-shirt size, here's small, medium, large.
Mm-hmm.
If you want an aggregate for a 3-year TCO exercise with an ROI number, I will build that for you.
By the way, we all know that a 3-year TCO is complete fantasy, right? Like, oh, we've done it for you, but like nothing in here is actually going to be accurate in 60 days.
These things change.
Yeah.
Business changes. Everything evolves. But if that's the thing that you need, we will build it. We will take the assumptions. We'll run the calculations. We'll tell you this is what it is. And so that ends up being the big focus, because at the end of the day, it's still people who are in decision-making positions, who have to adjudicate the risk and the business outcome and make a decision. And we have to engage with people, respect everything they've done before, show them a path on how this could make their lives easier and deliver certain business outcomes. And that's the journey. It's not the glamorous technical response of, oh, fast coding and do this.
My brother's line that I will always steal from him is, just be easier to work with. And like, if you do nothing else, just be easier to work with it. And he's like, and his point is like at every stage of the process, right? Can I call you on the phone?
Mm-hmm.
Can I buy something from you? Can you ship it to me? Can I receive it? You know, like, we talked about AI hype, you know, but what does it actually mean in terms of like networking and the networking world? And a lot of your examples actually is fascinating, because it's like cloud to cloud, cloud to data center, you know, data center, edge to cloud. Like there's all these, you know, like always in any, I mean, graph, right? Graphiant, you know, go figure. But in all these things, it's like the complexity as you add nodes. It's not just like, you know, it's like you go from 1 really simple, and then you go to 3 and you're like, okay, we're still relatively simple. And you go to 4 and you're like, all of a sudden there's a lot of lines there. And you go to 5 and you're like, now there's a lot. And you're like, all of a sudden you turn into like 15 and you're like, holy smokes, there's a lot here. But what's fascinating about that statement to me of like cloud to data center is these are east-west issues, right? This is a lateral issue within the network. And so, you know, are we really like, is this really like new architecture, or is this just like we're now actually finally addressing something that's been ignored for a long time of actually solving the east-west lateral issue inside of networks?
It's definitely the latter, that we've kind of not bothered with it for a long time. Because when you think about the transition where MPLS VPNs were for voice and it was fine. And so we solved that any-to-any communication, but it was voice, and we didn't really bother with anything else really. You get to the overlay networks with the SD-WANs and IPsec VPNs. Okay, we need encryption and we need policy control and all these things, but we're still north-south. It was hub and spoke. We didn't bother with anything else. We added cloud, but cloud just added so much complexity, and that was it. We didn't actually solve the east-west problem because it required interacting with the underlay. It required understanding what the network cores were, how the edges were distributed, what was a data center, what was not, where was compute, where was storage, almost treating the wide area as a mesh, as a service mesh. We didn't look at, what Kafka has done on the message bus side, what other things have done, what storage fabrics have done. We didn't do it for the wide area network. I think this is that moment of looking at the network cores and the carrier cores to go, why does it require a config change? This has to be done at the source. This is an east-west, north-south, any direction movement. This is a data movement that should be set by the source on where it wants to go. And the network builds it based on whether it's label switching, whether it's metadata tags, whatever you choose to call it. It's end-capped and the logic is carried with it. So context and intelligence carries that information, and it is with the packet itself. So when I think about an AI world, when I think about network engineers and operators building these networks now where they are just told, that cluster is over there, that data is over there, build a path. That should not be a change control of a whole bunch of configs and ACLs and firewall rules. Their life has to be made easier. Build a network. And then eventually they're going to program agents to do that. When a certain network engineer with expertise goes, I'm going to write this kind of engineering agent that builds networks in this way because I have a discipline on how I used to look at the router configs and what steps I would take. I wouldn't put the BGP config until I had put in the router ID at the system ID level because I know it would create a conflict later. All those nuances of how you do your job have to be made easier for you to do it. So you get more time to do other things. That's the east-west, but more importantly, broadly, I think, dynamic network programming. You should be able to program in any direction. I want that cloud region. I want that GPU cluster. I want that data set. I want this underlay carrier with these SLA attributes, and this is what I want. And this is the attributes and policy construct I want around it, and this is the security wrapper encryption I want for it. Build.
So, so you said publicly, right? I'm going to read the quote. Infrastructure must be directly programmable by AI, not config automation wrapped.
Mm-hmm.
What does that actually mean, right? Because we've been sold infrastructure as code and config automation and like these different processes for a long time.
Mm-hmm.
What is the difference?
The big difference that I envision, we're not there yet by any means. Where we want to get to is if we are at a point where the networks understand the different contexts that can be set in the headers, then the application itself can write to the headers to say, when you build basically an application and deploy it and say, this is the patterns that you want for it. It is a business critical application. It needs the highest SLAs. It wants this kind of QoS. It wants this kind of data sovereignty. It wants this kind of PCI requirement. Right now, that sits somewhere else that we configure, that we push down, and goes into the system. If it was protocol, and it's basically in the IP header itself, why can't the application write it itself? Now, we may have made the argument that a whole bunch of applications and getting a bunch of app devs to understand networking will be hard. If they don't have to do it, they don't need to. It's easier to just write the code that they already have to write in the first place. But now, with the systems that we have with AI, it becomes the question of, why can't we add that? Why can't it add it to the headers into the IP packet as it sends it?
Okay, so I hear two things when you say this, because I'm a comparison brain guy. I immediately hear like you're inventing a new routing protocol, effectively, right? Because what is a routing protocol? You have a source, you have a destination, you have something going on. The router then says, okay, I need to send this traffic in this direction. Now, it's a little bit deeper than that because you're also exposing and saying, encryption, QoS. But if the network is taking and reading whatever is in that header and then making decisions based on that, to me that goes, okay, we're talking about a routing protocol. Now it's a lot more than a routing protocol, but it's a routing protocol.
It is. And I would say this is where we distinguish, where we're saying we're not building a proprietary routing protocol. We're looking at how do we take the MPLS VPNs, BGP, segment routing, and extend those. How do we make that more easily palatable for somebody who does not have the deep expertise of MPLS VPN, segment routing, and BGP?
So how do you do that without shooting yourself in the foot? Because BGP and FlowSpec, right? What happens with that? People do all sorts of intentional accidental things inside of BGP routing all the time without realizing it. Maybe that even like, oh, you can't path prepend 57 times and have, what happens to the routing table. Or, FlowSpec. FlowSpec has this really interesting idea when it comes out of like, oh, you can now influence upstream routing and policy and ACL and whatever else you want with a tag inside of the BGP announcement itself, right? And this other thing, I'm simplifying this too much, but they'll get the point across. And what happens? Okay, some carriers roll it out. Exceptional disasters take place, and then everybody goes, oh, whoa, we got to put the training wheels back on, right?
It comes back to where the state machine lives. If you are going to propagate all of that state through the backbone core, you will do this to yourself. If you eliminate state from the carrier core, your blast radius is the source itself. It's going to shoot itself in the foot if it tries to do something weird. You are not going to be able to inject a thing that takes over the entire backbone. Because if you build the full BGP route table with all the address families and everything else into every core node, then yes, your entire blast radius is your whole network, because your state machine is propagated everywhere. It's why BGP has the challenges it has these days. You can hijack it, you can inject things, you can do all kinds of things because that state machine is propagated everywhere.
Well, and also because all these protocols came out when it was a place of trust.
Yes.
And these things weren't concepts. Also, when BGP was invented, the size of the routing table,
So small.
like it was like, okay, we don't need, this isn't a problem we have to deal with right now. Of course, we're looking at, you need to have, 4 gig of TCAM if you want to even plug a device in, and that doesn't give you any overhead. So, you touched on data sovereignty. I want to come back to this for just a second, right? Like, how much of this is this a real architectural issue of a network, or is this like now, we've got a compliance and governance model that we have to impose, and so therefore, as a result of it, now we have to actually, again, customer requirement, right? Mm-hmm. How much of this is actually native into a network going forward, and how much of this is just marketing that says, yeah, stamp the box, we can do this?
No, it's definitely a native requirement more so. I think geopolitics has a huge effect on this. And we, in the U.S., haven't been the best stewards when it comes to these kinds of things. We've let it be Wild West because we operate that way ourselves. It's like, all right, we'll figure it out in post.
Mm-hmm.
So it's really a case of too much infrastructure, the concentration of it in the data centers, in the hyperscalers, and it's still dependent on a classical IP network that was built at a time where trust was actually there, to what you just said, right? Which is why you now have the biggest outages are network-related outages. DNS.
Oh, geez. It's always DNS.
BGP, AS numbering, like it's some foundational stuff.
Yeah.
And when it happens, it knocks out everything at like a worldwide. We have gotten to a point where people don't even bat an eye that SLAs get missed.
Yes.
Oh, Slack and Teams and everything is down for the whole day. Everybody go home. Just is.
I heard an argument, which was the reason why you want to be in AWS US East is because that way when it goes down, the entire planet's down as well, and it's not, like you're not some outlier.
I have heard the same thing.
Yeah.
I've heard literally the same thing, and it's wild that's where we've gotten to, that's acceptable. So it's the case of we've definitely been wild on the US side. We've definitely played fast and loose with some of the models. I think internationally more so than domestically, there is that concern around, well, yes, when Virginia goes down, everybody goes down. The rest of the world doesn't feel too comfortable about that. So there is definitely an element of we need to bring that back. It wasn't just for SLA. I think AI accelerated it even further because your national data, your citizens' data, your healthcare, your financial data, that has now ramifications if it exists somewhere else. And so now there's even more about how do we contain the flow of data that is important at a national level. And then you get into the politics, the wars, the everything else that happens, where now there's increasingly going beyond just thought pieces that data is a national security commodity, just like oil or energy. It has to be treated in policy that way. And so you're seeing regulations come out with real teeth that you have to make sure that the networks are sovereign and compliant to making sure data stays sovereign. Not here, but pretty much everywhere else. And so if it might have been marketing 5 years ago, it isn't now. There are rules and there are harsh penalties.
Oh, geez, yes. I hate the Europeans for making me click cookie consent banners. And I love them for, the other side of it, right? Like it's unfortunately one of those, like,
it's the double-edged sword, right?
Yep.
Now you know how much of your data was being scraped
and
sold. But at least now you are forced to give consent, which a misnomer, I suppose, if you're forced to give consent to use a website.
Well, no, what I want is I want a browser setting that says you do not have consent to do anything but necessary cookies. Never ask me again, right? But that'll never happen. And the good thing about technology is that there's always it's like nature finds a way, right?
That's true. It's been funny to see Brave had taken off as a and then Firefox has returned with some real responses.
Yeah. Okay, let's round this out here and take it home. What is a question that buyers ask that think makes them look sharp, but isn't actually getting them the answer that it should be?
Ooh. I think the question that sometimes, and this will happen within the same meeting where different people from the same customer will say it, and you'll see it in that moment where someone will say, I want outcome-based business. It's like, in principle, yes, I agree with you. Everything you're saying, 100%. Somebody else will say, how do we do that through procurement? And it's like, okay, yes, we want to move to that world, but you have to spell it out beyond just that. What do you want? When do you want it? How quickly would you like to have it? And then we can give you a much more material answer as opposed to saying, this is just outcome-based. Because we understand where that brain is coming from, right? Where an executive in particular is like, there's so much going on. I just need this. This is the outcome I want. But just asking me that question of, well, how are you going to deliver this outcome isn't going to get you the full answer. It has to be a much more rich answer because I have to fit within the framework that your organization works with.
So what's the question they're not asking? And what would be the honest answer to that if somebody did?
I think the simpler language we can use ends up being the thing, which is Graphiant, your network as a service. What are you going to do for my costs? Are you going to make it easier for me to build my network for all the different use cases I have? Are you going to make it easier to operate? Tell me how you're going to do it. That kind of simple language allows us to give a very, very honest answer without the marketing fluff. It's like, this is how this works. This is what your engineers will do. This is how it's going to cost. And it will deliver the outcome you want. But if you start from a very broad outcome without giving me some substance around what you're trying to accomplish, it'll be a little markety around, well, this is what you can do with AI, and this is what you can do with data, and this is what you can do with... Let's bring it down to something that I can tangibly do for you right away.
So you're on the other side of the table, and instead of building and selling, you're buying. The market's really messy. What is the top thing that you would be looking for to actually differentiate hype from reality to make a decision?
I think there'd be two competing forces here. First would be, if I have a mandate from the board and from my executives about AI adoption, I would just be like, can you give me a real insight into what is happening inside my infrastructure? How much of it is real AI and how much of it is not? Like, what are the data patterns? Is our data even being used for AI purposes, or are people just chatting? Give me a measure of what is happening. Give me a data point to make sense of it. So I can tell my board and my leadership, where is AI adoption? How far have we adopted? How much traffic load, how much of our infrastructure load is now AI? If it's still 2% of our infrastructure, we are not an AI-first company. If it's 50, 60%, okay, that's a lot of traffic going towards AI. That would be item one for an executive. The second one would be infrastructure always requires rationalization. If you are concerned about cost and spending, operational efficiency, network as a service is a very powerful vehicle to get money back. There are people I know, clients of ours, some of them made bonuses the year they signed because it saved them that much money. And there's always going to be those adages, right, of how do you help me make money? How do you help me save money? How do you help me stay out of trouble? And with network as a service, the carriers are primarily the beneficiary of how do you make money. Everybody else will certainly save money because it simplifies the business process. It simplifies operations. But when you really think about the staying out of trouble and looking ahead, you want risk, you want compliance, you want trust, but everyone is telling you to do AI. You need a way to quantify Is it even happening? What is the adoption across my infrastructure?
Awesome. Ollie, thank you very much.
Thank you for having me. This was fun.
It's not too painful, I hope.
Not at all. No, it's actually enjoyable to sit down and sometimes just talk through the things that are happening and everything that's affecting us.
No, it's fascinating. Thank you very much. I appreciate it. That's it for this episode of Signed. If you got something out of this, share it with someone in your world who's staring down a tech decision. A CIO, a CFO, a founder, a procurement lead, whoever. That's how the show grows. Everything from today lives at itbroker.com/podcast. Show notes, transcript, links to anything we mentioned. If you're in the middle of a real tech decision right now and you want someone in your corner without the vendor bias, that's what we do at itbroker.com. Schedule a call on our website. Buy tech without regret. I'm Max Clark. Thanks for listening. See you on the next one.